Welcome to Chapter 9.7, Pre-Algebra students. Today we're going to learn about the tangent ratio. So in previous lessons we found side lengths of special right triangles, and now we're going to use tangent to find side lengths of right triangles. Let's get started. This section is all about trigonometric ratios. So a trigonometric ratio is the ratio of two sides of a right triangle. The type we're going to be learning about in Chapter 9.7 is a tangent. That's one type of trigonometric ratio. It can be abbreviated by writing tan, T-A-N. So let's define the tangent ratio. The tangent of an acute angle of a right triangle. So remember, acute means less than 90 degrees. So the tangent of an acute angle of a right triangle is the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. Okay, that sounds a little bit confusing, so let me see if I can explain it in plain English. Imagine we're looking at the angle here, A. If we wanted to find the tangent of angle A, we would take the side opposite angle A, so that would be opposite right over here. So that would be side A, okay? Then the side adjacent means right next to, angle A, would be length B, okay? So if we wanted to write that using algebra, the equation would look like this. Tan A equals the side opposite of angle A divided by the side adjacent to angle A, which would equal, in this case, A over B. Let's apply this idea to a sample problem. So for triangle PQR, shown here, let's find the tangent of angle P. So tan of P would be equal to the side opposite divided by the side adjacent. So in this case, here's angle P. The side opposite would be 77 in length. The side adjacent here would be 36 in length. So our tangent is 77 over 36. Remember to always use the legs, not the hypotenuse, for finding the opposite and adjacent sides. Here's your first checkpoint for Chapter 9.7. For triangle PQR, find tangent Q. Now, in our previous example, we found tan P. Now we're going to find tan Q. To help you out, I put the formula for finding tangent here for you. Press pause while you work and come back for our next example as soon as you're finished. If you know the measurement of an angle, you can use a calculator or a table of trigonometric ratios, like this, to find the tangent of an angle. You'll see that here it's calculated for you. So for example, if you know that your angle measures 12 degrees, then you know that the tangent then is 0.2126. On this table, the trigonometric ratios are rounded to 4 decimal places. That's true also in your textbook. If you go to page 799 on your textbook, you can find a table just like this that will tell you the tangent of angles from 0 to 89 degrees, since the 90 degrees makes it infinite. Let me show you briefly, too, how to calculate this using the calculator on your iPad or iPhone. Open up your calculator app and make sure that your view includes all of the scientific calculator functions, like this. Usually this is when you have your phone in landscape mode. So you'll notice here that down in the corner, the calculator has a button that says rad. Make sure that says rad and not degree, D-E-G. If it says rad up here, you want to push this button right here. It should say DEG for degrees. You want to push that button so the rad disappears because you want to be in degrees mode. So you want that button to say rad, not degrees. Okay, that's step one. The next step is to enter the measure of the angle. So let's imagine we're trying to solve for the tangent of 18 degrees. So we're going to put 18 in the calculator like this. All right, so we've entered 18 into the calculator. Now to solve or to find the tangent, I'm simply going to look for a button that says tan, T-A-N, and it's right here. Okay, all I have to do is tap that tan button and I will get the tangent of 18 degrees. Here's the answer. We can round this to 4 decimal places just like our chart in our book does. So our tangent of 18 degrees would be 0.3249. Okay? You can also do this on a scientific calculator like we have at school. I can show you that process on your calculator in person tomorrow. The buttons are a little bit different, so it won't work exactly the same way as this. And here's your next checkpoint. Use a calculator to approximate tangent 10 degrees and tangent 75 degrees to 4 decimal places. Press pause while you work, and there's a final real-world example of using tangent ratio to close out this section. Here's our last example for this lesson. We're going to use a tangent ratio to calculate something we can't measure by hand, physically, because it's too far away. Scientists can use the measure of the angle at which the sun's rays strike the moon's surface to determine the height or the depth of a lunar formation. When the sun's rays strike the moon's surface at an angle of 6 degrees, like in this example, the edge of a lunar crater casts a shadow that has a length of about 4,700 meters. We can see that, even though we can't measure it with a ruler or by hand on the moon. So we can use what we know about tangent ratio to find the depth, d, in meters of the crater to the nearest 10 meters. Okay, so let's use tangent ratio to figure this out. First of all, what pieces of information do we need if we're going to use tangent ratio to solve this? So in our diagram, we can see that the length of the leg opposite our 6-degree angle is called d, and the length adjacent is 4,700 meters. So there are the 3 pieces of information we need to fill in to our formula. We know that we're looking for the tangent of 6 degrees. We know that the opposite is d, and we know that the adjacent is 4,700. So we would write our formula like this. Tangent 6 degrees equals d, the opposite, over 4,700, the adjacent. Using a calculator or using on the chart in our textbook, that's on page 799, we know that the tangent of 6 degrees is 0.1051. So 0.1051 equals d over 4,700. Now we simply solve for d. By multiplying both sides by 4,700, so multiplying 0.1051 by 4,700 gives us approximately 494, equaling our depth. So using tangent ratio, we were able to figure out that this crater right here is approximately 494 meters deep. The question asked us to round it to the nearest 10 meters, so we'll adjust our answer to be 490 meters. All right, and there's your introduction to tangent ratio. I'll see you tomorrow to do some practice problems.